कंडीशन होगी क्वेश्चन में, उस कंडीशन में z की जगह बस x plus iy पुट अप कर देंगे. दैट्स द ओनली थिंग टू बी डन. लुक, mod of in place of z x plus iy minus 3 whole upon mod of x plus iy plus 3 is equal to 2. This will be x minus 3 plus iy whole upon x plus 3 plus iy is equal to 2. So this will be square root of x minus 3 of whole square plus y square. This will be x plus 3 of whole square plus y square is equal to 2. Clear? Squaring both the sides. So we'll get 4 into x plus 3 of whole square plus y square is equal to x minus 3 of whole square plus y square. So this will be x square plus 9 plus 6x plus y square is equal to x square plus 9 minus 6x plus y square. So this will be 4x square plus 4y square plus 24x plus 36 is equal to x square plus y square minus 6x plus 9. So this will be 3x square plus 3y square plus 30x and plus 27 equal to 0. So this will be x square plus y square plus 10x plus 9 is equal to 0. This is the relation between x. In a way, this is the equation connecting x. Right? So these two results, that mod of z is the same as mod of conjugate z, and z into z conjugate is equal to mod z of whole square. These two results. Now look carefully. Mod z1 is equal to 1. Mod of z1 is equal to 1. Can we say that mod z1 of whole square is also equal to 1? Can we further say that z1 into z1 conjugate equal to 1? Right? Quit out answer. So what will be the value of z1 conjugate from here? 1 upon z1. Similarly, what will be the value of z2 conjugate? 1 upon z2. z3 conjugate, 1 upon z3. If we add these three, adding 1, 2, and 3, it will be z1 conjugate, z2 conjugate, z3 conjugate is equal to 1 upon z1 plus 1 upon z2 plus 1 upon z. Yahan tak koi problem? Now, conjugates can be combined. Z1 plus Z2 plus Z3 of whole conjugate equal to 1 upon Z1, 1 upon Z2, 1 upon Z3. Clear? जो हमें फाइंड करना है उसमें mod है. So let's take mod of both sides. Taking mod. If we take mod of both sides, mod of Z1 plus Z2 plus Z3 of whole conjugate equal to mod of 1 upon Z1, 1 upon Z2 plus 1 upon Z3. And this value is already given out to be 1. So mod of Z1 plus Z2 plus Z3 conjugate is equal to 1 as it is given. It is given to us in the question. Mod of Z conjugate is the same as mod of Z. So can we now say that mod of Z1 plus Z2 plus Z3 is also equal to 1? यहाँ पर reason mention कर सकते हैं. Mod of conjugate Z is the same as mod of Z. ये find करना. So it is the way we have connected various things. देखो आप यहाँ पर हमें इन सब की वैल्यूज इक्वल टू 1 गिवन थी. That means Z1 conjugate equal to 1, Z1 mod equal to 1. Squaring both sides, then Z1 into Z1 conjugate. Why do we need this relation? क्योंकि हमें एक वैल्यू गिवन है और एक Z1 plus Z2 plus Z3 हमें फाइंड करना है. तो इससे हमारे पास सिमिलर रिलेशन आ जाएगा. Z1 conjugate, Z2 conjugate, Z3 conjugate, इन तीनों को ऐड कर दिया. क्योंकि कॉन्जुगेट्स को कंबाइन कर सकते हैं तो Z1 plus Z2 plus Z3 और 4 conjugate equal to this, taking mod of both sides. जब यहाँ mod आ गया तो ये equal to 1 हो गया. Then mod of conjugate is the same as mod of the main complex number. यहाँ पर हमने mod कर दिया. Right? Clear? The next exercise of the complex number is based on one simple fact that each complex number actually represent a point on the complex plane. Like for example, if z equals a plus ib, it is actually representing a point a comma b. So z agar हमें given है 2 minus I, what will be the coordinate it will be representing? 2 comma minus 1. That is a plus ib represent कर रहा है a comma b, right? Every complex number a plus ib represents a point a comma b on the complex plane. So if the complex number is z equals 3 plus 4i, the point that will be represented by it is, loudly bol do thoda sa, 3 comma 4. If the complex number is minus 1 plus 2i, point represented by it, confidence नहीं दिख रहा है अभी तक. One simple thing, that if z equals a plus ib, it actually represents a point a comma b on the complex plane. So if z equals minus 1 plus 2i, it will represent minus 1 comma 2. Right? Is z equal to 3 minus 7i, then आप सब बोलेंगे या मतलब loudly? If z equal to 2 plus 4i, 2 बोलना होता है यार, रिकॉर्ड हो रहा है सब. So now look for it. Exercise 7.5. एक छोटा सा फॉर्मूला इसमें हो रहा है. The formula for area of a triangle. All of us know the formula for area of a triangle. What is that? Half base into height. That is not the only formula. That is one of the formulae for the area of the triangle. It is half base into height. We got Heron's formula also. This result that we are talking about is to be used when the coordinates are given. If all the three coordinates of that is vertices are given, then we make the use of this result. x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. This is the formula for area of the triangle. You note कर लो please. Half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. अगर किसी को याद रखने में प्रॉब्लम है तो आई कैन टेल यू द सिंपल ट्रिक दैट वी यूज फॉर इट. शुड आई? आपको ये तो पता है पहले 1 आता है फिर 2 आता है फिर 3 आता है. अगर किसी को सिर्फ 3 तक काउंटिंग आती है, उसको बहुत सारी चीजें गिननी हो, तो वो 3 के बाद फिर से क्या गिनेगा? 1 1 2 3 1 1 2 3 1. वी कॉल इट साइक्लिक ऑर्डर. व्हाट डू वी कॉल इट? साइक्लिक ऑर्डर. 1 2 3 देन अगेन 1 2 3. तो अब देखो बहुत आसान है ये. इट विल स्टार्ट फ्रॉम x1. व्हाट डज that is what comes after 1, then after that 3. So x1 outside, y2 minus y3, then plus in place of x1 now to become x2. What comes after 2? So this is y3 minus y1. Then what comes after x2? x3. What comes after 3? 1. So y1 minus 1. That's a simple. So done. Now look for it. Exercise 7.5. Find the distance between the complex numbers. Z1 is equal to 6 plus 7i. Let's write it as ZA. ZB as minus 2 plus 3i. ये दो complex numbers given है. We need to find out the distance between them. If ZA is this, what will be the coordinate of point A? 6, 7. Coordinate of point B? Minus 2, 3. We need to find out the distance AB. So the formula for that is the distance formula. X2 minus x1 of whole square plus y2 minus y1 of whole square. So this will be minus 2 minus 6 of whole square plus 3 minus 7 of whole square. So this will be 64 plus 16 equal to root 80 equal to 4 root 5 units. Is it difficult? Just a quick recap. ये 3 कॉम्प्लेक्स नंबर्स हमें गिवन थे, उन तीनों कॉम्प्लेक्स नंबर्स को हमने कोऑर्डिनेट्स की फॉर्म में कन्वर्ट कर दिया, x1 y1 x2 y2 x3 y3. Then area of the triangle, the complete formula. Here we have put up all the values. Mod of -8, mod of -8 is coming out to be 8, that is 4 square, right? The next exercise is based on polar representation of a complex number. Now, what is meant by polar representation of a complex number? What we write, that is z equal to a plus ib, this particular form is actually known as Cartesian form. Why we call it Cartesian form? Cartesian, that means Cartesian coordinates. Because this form can be converted to the Cartesian coordinate. जैसे हम vertices की form में उसको भी convert कर रहे थे. So that is the reason we call it Cartesian form. Then what is polar form? Look carefully. We know that this is real axis and this is imaginary axis. If z equals a plus ib, it will actually represent a point a comma b. Now, if we represent this complex number in the form of the distance from the origin, do you remember what is the distance from origin actually known as? क्या था हमने? Distance of a complex number from the origin is actually mod of z. Let me explain it to you. देखो, ये अगर a comma b है, that means ये वाला पार्ट a होगा और ये वाला पार्ट b होगा, right? By using Pythagoras theorem, what will be this distance? Under root a square plus b square, and root a square plus b square is what? किसका फॉर्मूला होता है root a square plus b square? Mod का, because mod z equal to under root a square plus b square. So this distance is actually mod z. Now, when we express a complex number in the form of this modulus and this angle is known as argument. What do we call this angle? Argument. So if we express the complex number in the form of mod z and argument, then that particular form is known as the polar form or polar representation. So polar form is actually z equals r cos theta plus I sin theta. This particular form is known as polar form. अब r कैसे find करेंगे? R equal to mod of z, which is root a square plus b square. R is the modulus. Then this angle theta is the angle or the argument. It is also known as amplitude. These are the terms that we use for it. Argument or amplitude. How to find out this argument or amplitude? Now look. To find out the argument of the amplitude, जैसे ये जो मैंने representation किए तो मैंने सिर्फ first quadrant में किए. The complex number can be in the second quadrant or third quadrant or fourth quadrant. किसी भी quadrant में हो सकता है complex number. So now, depending upon the quadrant in which lie, various values are there for the argument. तो इसके लिए सबसे पहले तो हम tan alpha find करते हैं, which is mod of b upon a. यहाँ पर that is, इससे हमारे पास alpha की वैल्यू आ जाए. Now, depending upon the sign of a and b, we can easily find out the argument. देखो, अगर a और b दोनों पॉजिटिव है तो इट विल बिलोंग टू द फर्स्ट क्वाड्रेंट. तो आर्ग्यूमेंट की वैल्यू अल्फा के इक्वल होगी. इफ a इज नेगेटिव बट b इज पॉजिटिव, तो कौन सी क्वाड्रेंट में होगा? a नेगेटिव b पॉजिटिव, दैट इज इन द सेकंड क्वाड्रेंट. तो यहां पर थीटा की वैल्यू होगी पाई माइनस अल्फा, क्योंकि 180 डिग्री से स्मॉलर होगा. अगर दोनों पॉजिटिव, दैट इज दोनों नेगेटिव हो, नेगेटिव, then they will belong to the third quadrant. तो यहाँ पर थीटा की वैल्यू होगी अल्फा माइनस पाई, then it will be अल्फा माइनस. और अगर पॉजिटिव नेगेटिव हो, then theta will be equal to minus alpha in the fourth quadrant. So this is how we find out the मॉड्यूलस एंड द आर्ग्यूमेंट। ये शायद देखने में अभी थोड़ा सा अजीब लग रहा हो, बट ट्रस्ट मी दिस इज वेरी वेरी इजी, डायरेक्टली फॉर्मूला बेस्ड। जल्दी से आप इसको नोट करो, फिर स्टार्ट।